Welcome to the Sci-Fi Show. We talk science and philosophy, and today we've got the band back together again, a full complement of two of the best atheist philosophers in the game, Alex Malpass and Dan Linford. Dan, where have you been? We've been doing a couple of shows without you. What's been going on?
Well, I've been busy. I've been off interviewing at various places. I'm on the job market right now. I've got a 1-year contract in my current position, so I need to find a place to go. If anyone out there knows of a tenure track opening for a philosopher, let me know.
Okay. And Alex, it's no longer dry January. So what are you drinking?
I bought this over the Christmas period and saved it. So it's an interesting title. It says it's a white chocolate strawberry. I assumed stout. I guess I didn't read to the end of the sentence. It's actually not a stout. It's a sour. So when I started pouring it out, I was expecting it to look like a Guinness, and it started coming out looking like this. So it's a bit odd. It's sort of growing on me a bit, but my first impression was that it was rank in my first taste. But we'll see what happens.
Maybe by the end of the episode, you're gonna love it. We'll see.
Yeah, so this video not sponsored by them, apparently.
Right, clearly it's not sponsored by them.
Probably a good brewery, I'm sure. It's fine. I'm just not man enough to enjoy sours, unfortunately.
Right. So one place Dan has been is on the Unbelievable Show, debating whether the universe needs a cause with David Liu. So today we're going to do a deep dive into this fascinating topic of causality. Can the atheist say the universe didn't need a cause and still be rational? But Dan, why don't you sort of lay out sort of what happened on this debate? What was this argument that was being made that the universe must have a cause?
Right. So I was invited onto the Unbelievable program to discuss with David Liu his forthcoming paper in Faith and Philosophy. It's a paper about his view that if the universe could have begun to exist without a cause, then we should think that it most likely began very recently as 5 minutes ago or a moment ago.
Didn't there used to be something called the Church of Last Thursday? The whole universe started last Thursday and was going to end next Thursday.
That's right. Yeah. So there's this view called Last Thursdayism. Various people have discussed this view. So there was a famous book in the 19th century called Follows, and there was also so Bertrand Russell discusses this idea in various places. David is aware of all of that and is discussing this very interesting issue. Like, why is it that we are justified in thinking that the past goes back to, say, the Big Bang? Is it because each moment of the universe's history requires a cause for its coming into existence, or is it for some other reason? And on David's view, if the universe could have begun without a cause, so in other words, if what's called the causal principle, that everything that begins to exist has a cause, if that principle is false, then David is going to say that we end up in this skeptical scenario where the atheist he thinks is forced to say that the universe is no more than 5 minutes old. I think David's paper does a really good job of laying out some of the issues involved, of summarizing a bunch of the relevant philosophy of religion literature. The paper also does a decent job of describing a bunch of the evidence that we have for the age of the universe. I do have my own misgivings of the paper, but I want to say that I really enjoyed having this conversation with David, and that even though many people are going to want to construe what happened between the two of us as some kind of debate, I really saw it as a conversation, that I think he's raising a set of interesting issues, and we were there to discuss them together.
Right. And hopefully we can expand the conversation here. But why don't we start off with the first sort of part of the argument? Let's hear what David has to say.
If the universe began uncaused, then there would be nothing to constrain the initial state of the universe to be the Big Bang state. There would be nothing to make it the case to constrain the universe so that its first instant of time is what it was at Big Bang than what it was, maybe 5 minutes ago. For one universe to be more likely to begin to exist uncaused than another, there must be some underlying predisposition or bias that makes it the case that one universe is more likely to begin uncaused than another. But if the universe began uncaused, what we're saying is that the universe began by nothing and from nothing. And nothing, by definition, has no predisposition, has no bias. So if the universe began uncaused, then every possible universe could have begun uncaused. And it's equally likely that any possible universe begins uncaused.
All right, so that's kind of the first part of the argument. Before I come on to you, Dan, because you're going to have a lot to say on this, I want to just see, Alex, what was your thoughts on this presentation?
Well, the guy, David's not, as I understand it correctly, he's not actually a philosopher. Is that right? He's like a trained.
He's a medical student.
Yeah, medical student. So
I think he's done like a master's in philosophy of science or something. I can't remember looking at his background, but it's something like that.
Fair enough. I mean, the guy's obviously super smart, but all I mean by saying that he's not a philosopher is just that, like, it's quite impressive that he's formulating the argument like this, given that he's not got the background in it. So that I thought was really nice about it, actually. And we often critique people who make these types of arguments, and sometimes we make fun of them. But I, disagree with this guy. But I felt like he was a reasonable person and not being a complete idiot. So I just want to sort of put that at the table to begin with. Seemed like a nice chap. I guess my initial thought with this type of thing is that I feel sometimes like when people present the fine-tuning argument, that there's a bit of like, I don't want to say straw manning, feels like maybe that's quite a little bit over the top, but like there's something about like presenting the alternative hypothesis to the one that they're trying to defend in a way that's maybe not really what anyone actually thinks anyway, and I mean, I've yet to meet anyone who says, oh, the universe popped into existence from nothing, out of nothing. Like, I just don't think anyone actually defends that. So are we knocking over a hypothesis that's just kind of created for the purposes of being easier to knock down than theism? I guess there's some underlying worry that I've got there, right? I mean, you don't have to say, like, I'm inclined to think the universe just didn't begin to exist. And there's, in some sense, saying it's always been there doesn't really mean anything, because that's true if it began to exist or not. But like, it's saying that maybe it's eternal in the past or something like that. It just feels like it's a lot easier to defend that, because even these worries, if they're gerrymandered, they go away if the universe didn't begin to exist, because there's no from nothing out of nothing way of presenting the argument. So in some sense, I think like, there's a straightforward hypothesis that just is nothing to do with this that could be on the table, and that's not a theistic hypothesis. So maybe the universe just existed and eternally, and there's no God, right? And that's just not touched by this at all. So it's only the view that that God doesn't exist and the universe began to exist and popped into nothing out of nothing. So I suppose that's my initial thought, was that like we're carving logical space into two parts, but they're not actually, they don't actually cover all of the possibilities. There's a big chunk of logical space that's just left completely out of the question on this. So, yeah, I think that's my initial impression.
Right. But I guess you could run the argument, and I don't know if David does run the argument, because we haven't actually seen the paper yet, but my recollection was saying, well, if the universe had a beginning, then it must have a cause. Is that a way that we can think about this argument? Dan, tell us what you're...
And I have read the paper, and I think that's... if people are interested, there's a preprint that's available online. I think that is the way to understand what it is that David's trying to argue. I mean, ultimately in the paper, he wants to deliver a full-blown argument for theism, but I think that maybe that's a little bit too much to ask out of his paper. I think what the paper primarily tries to do is to establish one premise from the Kalam argument.
Mm-hmm.
And the version of the Kalam argument that he's interested in is a version that, for example, Craig presented when he was debating Sean Carroll. So when Craig debated Sean Carroll, Craig presented a kind of modified version of the argument. It said that if the universe began to exist, then the universe has a cause. The universe began to exist, therefore the universe has a cause. And that version of the argument involves this modified causal principle, where like the usual causal principle is that anything that begins to exist is a cause. The modified causal principle is that if the universe began to exist, then the universe is a cause.
Modified version of that premise is an entailment of the first one, right?
Right. So one is a narrower version, but you can imagine that. Here's a possible way that things could be. It could be that there's once you have a universe, there are things in the universe that come into existence without causes. But nonetheless, the universe needs a cause for its existence. So there's at least this possibility that that you can have one of those principles without having the other. Now,
I always found that a bit
Yeah.
strange, because the way I thought about it was, well, if there's anything we're not sure about, is how the universe came into being. Right, the things in it, we're probably a bit more confident about. Whereas it seemed like a weaker version of it. I don't know why it was.
Well, any sort of like inductive support, for example, that you might have for such a principle, if you're not looking at the like items within the universe, then it seems strange. I don't know where the support for the principle is going to come from. Maybe one place where it could come from is from David's paper, right? So maybe the alternative is that you have this skeptical hypothesis. We don't want that, and so we have to have the modified causal principle. Now, one thing that was odd to me about David's paper, and it's something that is odd to me about not just about this particular paper, but it's sort of a feature of the literature more generally, is that often defenders of the Kalam argument make this implicit move. They say, look, causes, and there's even a paper, there's a really nice place in David's paper where he does this, where he says, look, causes constrain their effects. And then he moves from that somehow within the paper to saying that if something doesn't have a cause, then it's unconstrained. And of course, that doesn't follow, right? Like I tried to point this out at the beginning of the debate that, if you're imagining that a wall is painted or ends up painted without having been caused to be painted, so I guess in that sense it's not literally painted, or there's no painter, right? Because there's no cause of it being painted. Then you can ask, well, does that mean it's completely unconstrained? Well, I mean, there are constraints, right? So it couldn't be that the wall is simultaneously white all over and black all over. That's metaphysically impossible. It couldn't be that the wall is painted with, I don't know, like maybe we call it like ectoplasm or something, like some substance that's metaphysically impossible. And it couldn't be that the wall ends up painted in a way that gives you a counterexample to Fermat's last theorem, because there are no such counterexamples, right? So there's all kinds of ways in which things are going to be constrained, even if they are not caused. Now,
I took it that when you were making those objections, what you're saying is something could be constraining it, just not causal constraints, so like logical constraints.
That's right.
Or something instead.
Logical constraints, metaphysical constraints, nomological constraints.
Yeah, of course. But then the point, as you started off saying it just a moment ago, sounded more general than that, right? Which was just something like X constrains Y, right? There's no X, therefore there's no constraints on Y. And that's invalid, not because you have to appeal to something like logical constraints or something. I mean, like, I guess logical constraints is a way of illustrating the point, but some other causal thing could be constraining. I mean, like, if you say friends constrain your personality in some way, they influence you for the better or something. Therefore, if you've got no friends, you're completely unrestrained and you could do anything. No, other society is still constraining you. Like, your enemies are constraining you. I don't know. But, like, the point is just, there was just something it's just invalid, right? You don't need
There's a distinction in logic between, like, a counter model and whether or not, like, an inference is logically valid, right? So for people who don't know, the distinction I'm talking about here is that sometimes in logic there's a move you can make from some collection of propositions to another proposition that's what we call truth preserving. In other words, that these propositions entail the proposition that we're interested in. And then there's another feature that you could talk about that's closely related, but is actually distinct, which is that you could show that one collection of propositions doesn't entail another one, by showing that the collection can be true of something, even though the third thing isn't true of it. So so when I'm saying that there are these other examples of constraints, I'm giving a counter model. And then what Alex is pointing out is that in addition to there being a counter model, there's just the more general logical feature that, in fact, the premise that causes constrain their effects does not entail the conclusion that without a cause, nothing constrains an effect. Or I guess, well, whether we want to call it an effect or not is it's a further semantic issue, right? But there's a really important issue to be brought up here, and it's one that I tried to raise in the debate. I kind of screwed up the precise technical terminology that I was using in various places. Some people in the comments on YouTube were a bit harsh that I did that. I don't think it actually matters for what I was saying, that I made some technical glitches. But I do want to.
I should just add, when you go on, I've been on Unbelievable loads of times, and every time you go on, you go, oh, God, I wish I'd said it that way. And when you're on one of these shows, it's it's not like you've got a prepared speech, and you're riffing, and sometimes you don't say it exactly right.
That's right. So there's a feature that a space-time can have. It's a feature called maximal extendability. And roughly speaking, it's this feature that a space-time is as large as it can be. Another way to think about it is that it has no arbitrary boundaries. The only boundaries it's allowed to have are non-arbitrary boundaries. And now if you have a
can I just stop you for a
Yes.
sec, Dan? Does this imply, well, the universe could be infinitely big. So are we saying, well, it could be infinitely big, therefore it is infinitely big? Surely that doesn't seem right. What's really being said here?
So right. So one way to think about this issue is that there's a theory that we use to think about possible spacetimes or possible universes. The theory is called general relativity. There's a central equation in that theory, the Einstein field equation. And when you're in say high school math class, and they give you these quadratic equations, and then you set the quadratic equation equal to 0, it will solve for the roots of the equation, right? So those are the numbers that satisfy some condition that you've set up. Likewise, the Einstein field equation has solutions. Each of these solutions, in fact, there's infinitely many solutions. Each of these solutions is itself a possible spacetime. So when we talk about a spacetime model, one of the ways that we can think about them as the solutions to the Einstein field equation. Technically, if some viewers might know this, that the space of possible spacetimes is a little bit broader. We can think about spacetimes too that don't solve the Einstein field equation. But basically, we're just thinking about this zoo, this collection of mathematical models. And the question here is something like, so if I give you one of these models, I can imagine taking a particular model and then truncating it, making it smaller, and then someone could say, well, why did you cut off those other parts of the model? Here's how that relates to what David's talking about, right? So if you imagine last Thursday's, the hypothesis the universe began last Thursday, that is the hypothesis that you take one of these space-time models, whatever one we think represents our universe, and we truncated it last Thursday, right? And so the hypothesis the universe began last Thursday is a model that's not maximally extended; it's instead truncated. And there's a debate in philosophy of physics that's related to this feature. So I've got a couple of slides that I can show. So we have this condition, maximal extended spacetime. What does that mean? Well, roughly a spacetime S is maximal extended, just in case S cannot be what we call isometrically embedded in a larger spacetime. And a truncated spacetime is one that is not maximally extended. So on the left here, we have a region from a spacetime. You can imagine that as itself one entire spacetime, but it's truncated. Why? Because we could make it bigger. On the right, we have that same region, but embedded in a larger spacetime. Now, one of the things that you can find in a spacetime is a thing called a future light cone. So if you imagine all of the light that you can send into the future, it's going to come out of you in an expanding sphere. If you imagine, for example, all the radio signals that the Earth has been transmitting since the dawn of radio, they are expanding out from the Earth in a sphere. And if you take that sphere, but if you want to represent it in a diagram, you have to cut away a couple of dimensions. If you cut away a couple of dimensions, you'll get a circle or a line. If you want to represent it here on the screen, we have to use a line segment to represent where light is at each time. So imagine that the light segment expands as time advances, which is to say, as you go up the screen. So the future light cone is represented by those two 45-degree lines. The future light cone is the interior of those two 45-degree lines. Likewise, we can talk about the past light cone. This is all the light that you can receive. And it's just the exact mirror image of that future light cone. Well, we can think about the region that's the intersection of the past light cone from one point and the future light cone from another point. That will make a triangular region, right? So that's like
A triangle?
if you imagine
Diamond
going
shape.
from what's that?
A diamond-shaped region, not triangular.
That's, yes, thank you. A diamond-shaped region, yes. Right. It's two triangles on top of each other,
Yes.
which makes a diamond. Right.
Two cones on top of each other.
Two cones. That's right. That's right. And really, in a full space-time, it's two hypercones. But again, we can't represent that on the board, so we think about that as a diamond-shaped region. And now do this. Imagine that our diamond satisfies two conditions. But first of all, it's compact. Basically, just means that the region is finite. That anything that goes off into this region doesn't escape off to infinity while still remaining within the region. And also that there's no time travel shenanigans within the region. There's no closed time-like curves, right? So a closed time-like curve is just a curve that intersects with its own past. So that would be like if I hopped into a time machine and then I went back in time, and then I became my own former self and hopped back into the time machine. So I went in this closed loop. You can't have any time travel shenanigans like that inside of this diamond-shaped region.
I should just make a quick diversion that in our upcoming book, Battle of the Big Bang, we do have models of the universe where there are closed time-like curves.
Yeah. Right.
They're
So
quite funky. But anyway, we'll move on, but just a quick aside.
Yeah. So actually, this is really important because I'm not saying that a diamond-shaped region like this couldn't have closed time-like curves. What I'm trying to do is I'm trying to set up a particular condition that's going to say if space-time is such that in a diamond-shaped region like this, that you don't have closed time-like curves, and something else is going to follow, right? So Phil's exactly right. You can, in general, have closed time-like curves, and you can, in general, have diamond-shaped regions like this one that are not compact. But what we want to do is we want to focus on an example where both of those two conditions are true. And then let's imagine that both of those conditions are true for every pair of points inside some set of points. Okay? And let's call that set of points S. Well, then in that case, the whole set of points, we say that the whole set of points is globally hyperbolic. And so if both those conditions are true for all the points inside of this, for every pair of points inside of S, then S is globally hyperbolic. But let's take a look at one contrary example. Phil already brought up one where you could have a diamond-shaped region where there's some time travel shenanigans. Here's another counterexample. So you could have what's called anti-de Sitter spacetime. And if you look at the diamond-shaped region here, you can see that it sort of opens up from both directions. And in fact, if you're coming out of the point Q, for example, you could escape off to infinity and never reach up with P. This also means that in anti-de Sitter spacetime, an object, and actually any like arbitrarily chosen object that you want, can come in from the boundary of spacetime infinitely far away and can meet up with P, so that and maintain and reside entirely inside of this diamond-shaped region. So that's a really strange kind of spacetime. By the way, this diagram is from page 19 of J.B. Manchek's 2020 book. But that's what it would mean for a region, for a set not to be globally hyperbolic. Now, why do we care about any of this? Well, there's one important implication that if an entire spacetime is globally hyperbolic, so if every pair of points in that spacetime satisfies those two conditions that I told you about, then you can divide space-time up into something that you can think of as analogous to a sequence of moments. Technically, in general relativity, we ordinarily think of as moments. We don't have that feature anymore. But you have something like moments in a globally hyperbolic space-time. Those things that are kind of similar to moments we're called Cauchy surfaces. And if you live in a globally hyperbolic space-time, then you can predict the future based upon the past. So you get this condition that's something like what philosophers call Laplacian determinism. Right? So that's how you might have intuitively thought things should be, that if you understand how things are in the past, then you're going to be able to predict the future. Well, you have that condition if space-time is completely hyperbolic. And if you don't have that condition, so for instance, if you live in anti-de Sitter space-time, then basically anything at all, with no constraints at all, not even a probability distribution over these things, could come into existence and appear in front of us. So if you don't live in a globally hyperbolic space-time, and if you live in one that has the kinds of features that anti-de Sitter space-time has, then it's possible for something just to pop into existence at the boundary of your space-time and then to appear in front of you, and for that thing to be absolutely anything at all. You might think that that's not metaphysically impossible, and in fact, you might think that something like Laplacian determinism is metaphysically necessary. If all of that's right, then you might think that space-time must be globally hyperbolic. So here's something to think about. There are some space-times that are not globally hyperbolic, but they include a globally hyperbolic region. Sorry, my chair is like getting out from underneath me. Right. So you have some space-times that are not globally hyperbolic. They include a globally hyperbolic region. One example, if you want to look it up, is something called Meissner space-time. So suppose space-time must be globally hyperbolic. Well, then your space-time could be this particular region from Meissner space-time without being all of Meissner space-time. Right? So in that case, instead of thinking about space-time being maximally extended, you instead say that, well, the largest that it could be would be maximally GH extended, where if you were to extend it any further, then it would no longer be globally hyperbolic. So the debate in philosophy of physics is a debate over what the correct extendability criterion really is. Should we think that space-time must be globally hyperbolic, or should we think that space-time must have some other additional feature that would carve out some boundary somewhere? In the debate with David, one place where I screwed up was that I said that it was uncontroversial in philosophy of physics that space-time is maximally extended, right? So what is basically uncontroversial is that it has to satisfy some kind of extendability criterion. What exactly that criterion is, it takes a little while, as you've seen, to unpack. Now, why else do we care about that? We care about that for another reason too, and that's because when we think about cosmology, we care about whether or not the Big Bang, whether or not the universe must have begun in, say, the Big Bang. So when we go to the broadest possible extendability criterion, that maximal extendability criterion that we started with, that's usually a criterion that's baked into the way that we think about singularities. That a space-time singularity is supposed to be a kind of boundary past which you couldn't extend space-time, right? So the reason to think, if you do think it, that the universe began in the Big Bang is because the universe can be modeled with a model that cannot be further extended, right? It's not because the universe was hot and dense in the past. You could imagine the universe going through some period of being hot and dense without there being a boundary past which you couldn't extend time. Instead, it's because there are models in, for example, general relativity, where you're not allowed, in virtue of the laws of physics, to extend space-time further. Now, the proposal that I made in the debate was that space-time is necessarily maximally extended, and if that's right, if space-time must be maximally extended or must satisfy one of these other extendability conditions, then it would be metaphysically impossible for space-time to have begun last Thursday, right? The only way that that's possible is if you're in a truncated model. Now, David, in various parts of the debate, tries to say, "Oh, but couldn't there be, couldn't you be located in some model, someplace where you're close to the Big Bang?" Well, yes, but we look around ourselves and not instantly vaporized, right?
Right. So that's because presumably you get close to the Big Bang and the curvature and the density is going up, 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 up.
Yeah,
So the
right.
temperature is going up, 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 up. And there's no way for you to survive. No conscious being could live in that kind of heat and temperature that we
That's
know
right.
about.
This
Right.
is a very
so
important.
We couldn't be in this close to the beginning, basically.
That's right. This is a very important thing that if you're looking at a Big Bang model, then one of the reasons you can't extend space-time further is because the curvature diverges. The curvature, to put it in simpler terms, basically becomes infinite. And there's no way to extend the space-time manifold past that boundary because of what the curvature is doing there. It's similar to what happens in the function y equals 1 over x. Right? So if you look at the function y equals 1 over x, you can't plug in x equals 0. Why? Because you can't divide by 0, right? So likewise, the space-time manifold at a particular point becomes undefined. It has a boundary that you can't push beyond. And so if you think that it must be extended up to the point where you find a boundary like that, well, then the only way that it could have begun last Thursday is if last Thursday the curvature was basically infinite, right? And then you'd be in the situation we find in the very early universe where everything is very hot and dense and so on. You can imagine instead a truncated space-time, but that's the kind of space-time that's ruled out if you think that space-time is necessarily maximally extended. So I think the debate here should really be over whether in the absence of the causal principle, or in the absence of the modified causal principle, is it true that space-time could be truncated? If it's not, then we don't get David's conclusion.
So is there another way of saying it then, that the question is whether or not we have reasons to think that space-time is globally hyperbolic? Because if it is, then is that right? Am I following correctly?
No. So
then it's maximally extended to 3. Is that right?
Well, if you think that space-time is globally hyperbolic, then you could get a modified maximal extendability criterion if you think that the global hyperbolicity is necessary. Right? If it's not necessary, then you don't need to modify your maximal extendability criterion, right? Like, the way to think about this is like this. Suppose that space-time must satisfy some condition. Call it P. Then you can extend space-time all the way up to the point where if you were to extend it any further, P would be violated.
Mm-hmm.
There are people who think that space-time is necessarily globally hyperbolic. You can point out that there are space-time models where you can extend them up to a point where if you were to extend them any further, they would no longer be globally hyperbolic. Mm-hmm. Right? So if you believed that space-time must be globally hyperbolic, then your extendability criterion would be that you get to extend it up to that point and no further.
Yeah. Right.
Now, if you take the broadest possible condition, which is the one that when I talk about in the debate, it's just the one where you say, we're going to extend space-time up until you get to a singularity. So if space-time turns out to be non-singular, then you just extend it forever. If there's a Big Bang singularity, for example, then you get to extend it up to the Big Bang and no further.
Okay, so I understand. I think what you're saying is that, like, if the universe was globally hyperbolic, then you couldn't extend it beyond conditions, meaning that it wouldn't be globally hyperbolic. It wouldn't be.
If it was necessary that it's globally hyperbolic.
Yes, that's right. If you thought that was a necessary truth, then the simple fact is just that means any modification of these models that pushes it beyond the scale or whatever where it's globally hyperbolic anymore, then they're just not possible anymore, because we just said
that's right.
The assumption is that all possible worlds are globally hyperbolic. So we've just constructed a world that's not hyperbolic in some specific place, means it's not globally hyperbolic, so it's not a possible world. Fine. But so that means it puts in the sort of top, if you take it to be necessary anyway, it puts a top limit on how much you can extend a universe. But that feels like it's not quite, it doesn't tell me that I have to extend it to the maximum. It tells me what the maximum is.
So that's right. So global hyperbolicity wouldn't do that. I'm not saying that it would.
No, it must be misunderstanding it.
Yeah. So that was an example of a property that some people have thought spacetime must have. But here's another property that you might think spacetime must have. That it's maximally extended, or as extended as it could be. Now, if you think that that's necessary, then truncated spacetimes are metaphysically impossible.
Sure.
And so then last Thursdayism is metaphysically impossible. Now, the place where this gets tricky, and this is part of what people pointed out so remember in the debate, I said that the proposal was that spacetime must be maximally extended, and I said that was basically uncontroversial. People in the YouTube comments said, well, wait a minute, and this other thing you wrote, you said that it was controversial. What's up with that? And the answer is that on the one hand, that spacetime is maximally, that it must be maximally extended is basically uncontroversial among physicists. The place where there's a little bit of controversy is among philosophers, and there's controversy there because there's debate about what exactly the right maximal extendability criterion is, right? So the most general criterion you can imagine is one where you're allowed to extend up until you get to a singularity.
Okay. Right.
And so that's where you can put a boundary in then.
Right. Yeah. Now the idea of all these different conditions is that if spacetime satisfies one of these extendability conditions, whatever it is, then it can't have arbitrary boundaries. Right? The only boundaries you're allowed are ones where something goes very wrong if you extend it past that point. And so something goes mathematically wrong if you try to extend a singular Big Bang model past the Big Bang. Something goes maybe metaphysically wrong if you try to extend the universe past the point where it would no longer be globally hyperbolic. And you can dream up all kinds of different conditions that you might have. But the point is, the boundaries that you're allowed to have under this proposal are ones that are non-arbitrary. Putting one last Thursday is an arbitrary boundary. And so that's the kind of boundary you're not allowed to have. And if you believed in a metaphysical view like that, then David's argument does not succeed.
I guess I'm sorry, I think I'm just being dense, but it sounds like, if I'm blowing up a balloon, right, then obviously there's a threshold of the amount of air I can put into it because it'll burst at some point. That gives me a good non-arbitrary limit on how big the balloon can be. But it doesn't tell me any, I think I'm still missing the basic thing. You probably explained it already and I'm not getting it, but that doesn't tell me that every balloon has to be as big as it could be before it bursts, right?
So I think you're confusing remember what I said was that there are various properties that you might think are necessary for spacetime to satisfy. And then you can point out that there are ways of extending various models such that you would violate one of those conditions. Now, that's kind of in a way, that's a kind of distraction because what's doing all the work for me is just the principle that spacetime must be maximally extended, or must be as large as it can be, whatever that ends up.
Yeah, exactly.
Whatever proper ways of casting it out. Now, there are various arguments you might give for that conclusion. One kind of argument you might give is one that's actually very close to an argument that David gives. Right? I mean, so in a sense, David is arguing for a kind of maximal extendability. David's saying that the reason that spacetime must be as big as it can be is because this causal principle is necessarily true. But the point is, you didn't have to think. You could have gotten to that conclusion without believing in that causal principle. You could say this. You could say, look, you might have a view according to which. Remember when I was talking about global hyperbolicity, I talked about how each of these what are called Cauchy surfaces necessitates or determines the others, you might think that there's a law of nature according to which, given any Cauchy surface, the rest of the space-time is necessitated by that one Cauchy surface. And so,
can we just remind the audience a Cauchy surface? Because I know you explained it before, but not everyone's going to know, and there's a lot to digest here. So just go over what a Cauchy surface is again.
So for our purposes, a Cauchy surface you can think of as being something like a moment of time. Strictly speaking, technically speaking, that's not quite right, because there are no such things as moments of time in general relativity, but it's a surface that cuts across the entire space-time block. And it has this feature that in any direction away from that surface within the space-time block, it determines everything else that's in that space-time block. So if you have a view about the laws of nature such that the laws of nature are necessitating. So for instance, like Ellis's view about laws of nature, where the laws of nature are made true by the essences that things have, then it's not going to be possible to have that Cauchy surface without having the rest of the space-time block.
Right. So and basically his argument is sort of saying, well, you could, when you're saying, well, you couldn't.
Right. Yeah. It would be a violation of the essences that things have. Right. It would be metaphysically impossible for that to be so.
So if we wind back to the original argument, we couldn't have the wall white all over and black all over because it's logically impossible. What you're saying is you couldn't have this sort of slicing up that boundary there because it would be sort of physically impossible. Is that a fair way to put it?
Well, it's not just physically impossible, right? So in some people's views about laws of nature, it would just be physically impossible, and we might worry about that. But in some views about laws of nature, like in Ellis's, it's in fact metaphysically necessary, right? So in Ellis's view, a violation of the laws of nature is not metaphysically possible. And we can look at, so there's this debate in metaphysics and in philosophy of science and philosophy of physics about why the laws of nature obtain. And one view is that the laws of nature obtain because of what are called necessary connections between things. That if you have one thing, then you must have another. There's another view about laws of nature in which laws of nature are just patterns. And then there's no necessitation. That's called the Humean view, the latter view. But if you have any non-Humean view, then if you have like any particular thing in your space-time, then it's going to necessitate what else you have in your space-time. So if you have like a Cauchy surface, for example, then it's going to end up being the case that all the other parts of the space-time block are necessitated, and then that gives you this justification for space-time being as large as it can be, and not having an arbitrary boundary.
Is it? I don't know about this. I don't really feel about this, but so if you take a sort of dispositionalist view like Ellis's, and thereby you end up saying something like the behavior of physical stuff and the metaphysical constraints on the behavior of physical stuff are basically the same. So like in metaphysical possibility and physical possibility is basically the same thing.
Yeah.
It sounds like it's quite hard to be a theist in that environment because like, it does seem like there's no sort of space for God to have a range of capabilities or something that goes beyond that. Like, I mean, traditionally you'd say God's omnipotence means that like any metaphysical possibility is available to God, right? But if they just become, if on this sort of view, metaphysical possibility doesn't outstrip physical possibility, then it seems to constrain God in a way that a theist would probably object to. And I wonder if it's just like cutting them off at the pass, and they would just go, yeah, but dispositionalism must be.
So I don't think we have that problem for two different reasons. So on the one hand, David meant this as to be like a reductio of the atheist view, right? So so David is saying, oh, the atheist should think the universe is 5 minutes old. I say, no, there's another way the atheist can go. But the other thing to be said here is that theists typically think that God is constrained by God's essence. Right? God never acts contrary to God's own essence. And Now, I suppose that there would be some difficulty for the theist that involves, like, I don't know, whether you could have miracles if you can't have a violation of natural law. But maybe they would just need to spell out what a miracle is in a different way. I mean, I take it that the theists don't typically think that a miracle would involve the violation of anything's essence. So if it turned out that that natural laws were just like some big compendium of all of the facts about the essences that things have, then whatever a miracle is wouldn't violate one of those, perhaps. I don't know. But again, I don't think that we really have this problem, because my role is to point out that the atheist isn't saddled with the problem that David thinks the atheist is saddled with.
Can I throw in another view of laws here? And this gets us back to a model of the universe that we've talked about before. And it's the one that I think is closest to what David is actually suggesting, which is a universe came from nothing, by nothing, whatever, without a cause. And of course, this is our...
Whatever.
Sorry?
By nothing.
By nothing. So, the closest thing that I can think of that, some atheists defend is the Vilenkin tunneling from nothing model. We've talked about this model. And here the universe, sort of space itself tunnels into existence from no space. And what Vilenkin needs for this model is a kind of weird theory of laws, that they're kind of Platonic, that they do actually push things around in some sense. So they have this sort of ontological existence independent of the stuff within it. Now, in this sense, in some sense, the universe from nothing, in that there's no material, but it's not from nothing in that the laws of physics exist. So in some sense, yes, some sense, no. Mm-hmm. Now, how would this relate to David's argument? Suppose we want to believe in this model. How would that relate to David's argument? Would he be able to carry that and use this argument, or is there a problem with that?
So, well, it depends upon what else the laws of physics might say. But the Vilenkin's view about laws is another anti-Humean account of laws. It's very similar to a view that's been thought about by philosophers called the DTA account, the Dretske-Tooley-Armstrong account, which is another Platonic account of natural laws. What's important about these views is that on any anti-Humean account, there's going to be a very strong sense in which it's impossible to violate one of the natural necessities. So if it's if it turns out to be some consequence of the natural laws that space-time is as big as space-time can be, then you're always going to get this conclusion that you don't have just an arbitrary boundary. If you have a view like the sort of view that David Hume had, or that David Lewis had, then perhaps space-time could have an arbitrary boundary. Right? So Lewis has this view that absolutely anything can be combined with anything else. And so you might think about this in terms of space-time regions. So you might think that any one space-time region can be combined with any other space-time region. One of the things you might think that a Lewisian would say was that you could just have the region instead of combining with another region. And then you could just truncate this space-time anywhere you want. The proposal is that you could have a view about laws of nature on which that's not going to be possible. On any anti-Humean view of laws of nature on which it's also a law that space-time must be maximally extended, or, insert whatever extendability condition you want, then you're not going to get something like last Thursdayism out the other side.
Right. And if I think about this in the context of the model, I can think, well, what's likely to come about is like various space-time fluctuations. And the only one that's going to probably lead to us, the one that's going to dominate the probability space, is not last Thursdayism. There's one that undergoes inflation, because that's the one that's going to grow into a big universe that can accommodate conscious beings. So therefore, we should expect some sort of natural evolution of the universe, not a last Thursdayism scenario. Is that kind of right? Or
yeah, I think that's right. Man, now we need to look back at Valenkin's model again. And by the way, I think we should say this just so that people don't bring this up in the comments. Valenkin's model is often confused for another model that sounds superficially similar, according to which you begin with a vacuum, and then you have things come into existence within that vacuum. That's not Valenkin's model. Valenkin's model is that you have, at least his interpretation of this model, is that you can trace the universe back to zero size, and then that's this non-arbitrary boundary, and that the universal wave function includes some weighty amplitude for that result, and that's where we happen to find ourselves in. It's one of these parts of the wave function where the universe once had zero size and didn't exist before that.
Right. Okay, shall we move on to the next clip? It's like we've done an hour on the first one.
I know.
And I don't know that we're going to have time. I want to make this 90 minutes, so we'll get through as much as we can in 90 minutes, and we'll go from there. So the next is this argument about the monkeys on a typewriter. Let's have a look at.
So imagine you're in a room where there's a monkey typing on a typewriter, and the monkey is allowed to type randomly on the typewriter for 100 pages. After the monkey is done typing 100 pages, if the monkey types less than 1 page of Hamlet perfectly, then the room explodes and you die. If the monkey types 1 or more pages of Hamlet perfectly, then you survive and the bomb doesn't explode. So you wait nervously as the monkey's typing, and after it types the 100 pages, miraculously, you don't explode and you survive. Now, let's say without looking at a document, I just ask you, which one is more likely to have occurred? The monkey typed 1 to 5 pages of Hamlet perfectly, or the monkey typed 5 to 100 pages of Hamlet perfectly. Obviously, it seems like 1 to 5 pages, right? Because the more letters the monkey had to have typed correctly, the less likely it is the case the monkey would have typed those letters in that correct order. Which one is more likely to have occurred? For us to get the impression that the universe is much older than it actually is, all that would need to happen if the universe is only 5 minutes old is for all the particles within our 5-minute light cone to be configured correctly to give us the appearance of age. However, if the universe is 10 minutes old, every particle within the 10-minute light cone, which would include the sun, will have to be configured correctly to give us the appearance of age, right? So as the universe...
So you can see how the argument works there. Basically, the bigger the light cone, the more improbable it is. So it should be smaller and smaller and smaller, and therefore younger and younger and younger. Each one is more probable than the next. So, I mean, is this basically the same argument that we've just reviewed, or is there an additional step that we have to sort of think about here? This notion of...
So it's roughly the same argument. I mean, so this is his conceptual description of the probability calculation that he offers in his paper, which is very similar to a calculation that Alexander Proust offers. It's not, it should be noted, the way that physicists would think about this kind of calculation. There's various places in his paper where David makes allusions to similar sounding calculations that physicists make, but that are ultimately not the same calculation. So here's a similar sounding calculation, and is one that does appear in physics. That the further back in time you go, the more improbable a macrostate you find. Not more probable configuration of individual particles you find, but the overall macroscopic state of the universe is more and more improbable the further you look into the past. That's basically just because entropy is increasing over time, and the most probable states are those that have maximum entropy. So if you are imagining the universe just popping into existence at any given moment, you're probably going to imagine a high entropy state coming into existence. And that's roughly the famous calculation Roger Penrose does, as opposed to the kind of calculation that David is describing, or the one that he takes from proofs. It's subtly different because Penrose's calculation simply does not say that any microscopic configuration of the universe at any moment of its history is any less probable than any other. instead the conclusion is about the macroscopic condition of the world. Right, and the argument there is supposed to be that the reason why the higher entropy states are more probable is because there are many more microscopic configurations that correspond to them.
Yeah, I should just point out, just for everyone to be clear, because not everyone will know this. So one way, I think the way that physicists define entropy is not the amount of disorder, as you'll often hear. I mean, that's roughly right, but it's more how many microstates will give you a certain macro state.
Yeah,
is that fair? That people need to know that. Yeah.
There's even more abstract description, but for our purposes, that's fine. If people want to be really tricky, they'll notice that. Also, they'll know that the actual definition is the integral or the sum of rho log rho, where rho is the probability distribution. But in any case, for the situation that this is normally considered, which is the one where you have a uniform distribution over microscopic states, then the entropy is just the basically the number of configurations of a system. That is the number of microscopic configurations that correspond to the macroscopic state. Right. So here's an example, right? I come across a big cloud of gas. I know the pressure, the volume, and the temperature from my cloud. Now I ask how many microscopic configurations could give you a cloud that has that pressure, volume, and temperature. That's basically what the entropy is telling you. And it turns out that as the universe advances onwards, the entropy is increasing. So from that perspective, the further you go into the past, the more improbable the macroscopic state is that you find. It's a little bit different than what David is saying, because David is saying that somehow the microscopic state, as you go further and further into the past, is less and less probable. I don't quite know what would justify a view like that, unless you thought that what you were interested in was like a configuration of particles that was just popping into existence for no reason. Because it popped into existence for no reason, you had a uniform distribution over all the different numbers and arrangements of particles. I mean, this is what Proust is thinking about. But again, it's based on this implicit assumption that if there's no cause and the system is completely unconstrained, and then if it is completely unconstrained, that you can then use something like the principal indifference, either the principal indifference or some close relative to it.
Right. So are they saying? I know so what you're saying is that that's not true. That it isn't totally unconstrained. Is that
right? So that was the original argument.
Line here.
It's not totally unconstrained, and then also, this isn't the way that I would have approached this calculation. It makes assumptions I don't agree with, and it seems to be out of step with how physicists would ordinarily approach this sort of issue.
I think you're seeing around a corner that I can't see around, because the way you interpreted this argument is very charitable, and maybe it's just the right way of thinking about it. But it feels like to me the way he said it, the actual words in the clip at least, was like, so you've got a monkey, he's typing on the typewriter. If he types out a page of Hamlet perfectly, you don't explode. If he doesn't type out the page of at least 5 pages, whatever it was, right? Something unlikely, then you explode. And then 5 minutes later, you sort of look around, I haven't exploded. I wonder what the chances are that he wrote 5 pages of Hamlet. And he must have done, right? He must have done, must be one. Right?
I think the argument was that if you know is so many pages that were written, you would assume the minimum amount that could be written, could be written. Not if you had to bet how many you knew that he got the minimum for you to survive, right? Now bet how many pages did he actually write? You've got to bet on the lowest one. I think, is that fair? Maybe I'm remembering it wrong.
That just sounds like you're making a much more reasonable argument than what was said in that clip. Well, maybe there was a more reasonable argument.
Part of the trouble is that
either you have to say, well, look, I'm still alive, so he must have done, or their question was just, how likely is it? right? And then it's just like super unlikely. There's nothing interesting. I mean, on either side of the divide, it just felt like, well, either one, because I'm still here, or you're not asking whether, like, the anthropic kind of reasoning of like I'm a selection effect kind of thing, but you're actually just asking how likely is it that a monkey would type 5 pages of Hamlet, in which case the answer is fucking unlikely. But what's interesting about that, like, it was one or fucking tiny amount, but I don't get like what's supposed to be so interesting about it. So I think you guys are seeing it as more of an argument that it's better than that. Like, maybe I'm just being tonight.
Dan, help us out.
Right. So look, I think part of what I have in mind is that, this is the way he's describing the argument for like a popular level viewer on Unbelievable. Then he has this
an idiot like me.
peer-reviewed publication, or a forthcoming publication in Faith and Philosophy. And so I'm trying to like translate what he says here into what he actually said in the paper. And in the paper, he doesn't talk about it in terms of like a sequence. He talks about it in terms of a configuration at a moment. And the other thing is that he's borrowing from proofs, right? So there's this argument that argument for the causal principle, that if the causal principle are false, then just like anything could appear in front of you.
Yeah.
And Proust has this probabilistic argument that is supposed to show some conclusion like this, that the most probable thing for you to see over the next minute is for some like random thing to appear in front of you. Of course, like the whole thing that's like driving this is like the two assumptions that are driving this is that on the one hand, that without the causal principle, then whatever happens is just completely unconstrained. And then on the other hand, that if it is completely unconstrained, then we have to be applying something like the principle of indifference. And actually what he is in the papers, he knows not to make use of the ordinary principle of indifference, actually for reasons that are similar to the ones we raised in our previous fine-tuning panel. But the issue,
Dan, let me just remind the audience, because not everyone would have seen it, right? So basically, principle of indifference, very quickly, you're on a game show and you're asked, the prize is behind one of 3 doors. You don't know which one, so you assign each one equal 1/3 probability. That's the principle of indifference. Now, it turns out there are contradictions if you just assume the principle of indifference. So people modify it and they use some different version of the principle of indifference.
So he likes Robin Collins' modified version of the principle of indifference. And then he tries to say that so Collins' view has this: you need to pick out a variable that's natural in whatever theory you're talking about, and the variable that David thinks is natural is a variable that ranges over moments in the universe's history. I tried to explain to some extent in the Unbelievable conversation why I think that that's a bad choice of a natural variable. But in any case, that's the basic setup, is that that he's assuming that if you didn't have something like a causal principle, then what happens is completely unconstrained. And that if it is completely unconstrained, that then you have something like a principle of indifference. So you have all these different possibilities, you have some kind of uniform distribution over all of them. And so the most probable thing to happen is, of course, not like the ordered things that we see happening. Instead, it's this weird other mess that
Can I just ask about Proust's version of the causal principle, or his thoughts on the causal principle? This is just something that occurred to me, and maybe they're rather silly. So, you can think of the most general causal principle, which is that everything needs a cause, right? Now, obviously, the theist does not defend that. They say that everything that begins to exist has a cause. So there's a slight modification to the most general causal principle. What if you come up with a slightly different modification and said everything that has a prior moment of time has a cause? Now, it seems to me I could say, well, therefore the universe doesn't need a cause, but I wouldn't be trapped by Proust's argument, because it couldn't be the case that things pop into existence in a second from now, because the condition for the causal principle is not met. Is met, but it wouldn't be met at the beginning of the universe. So it seems to me, and that seems to be as justified as the other version of the causal principle, which is that everything that begins to exist has a cause.
Well, let's
is that
remember
fair?
what David is. Let's remember what David is actually arguing, right? So David is saying that if you had a view like that, that some kind of causal principle applies within the universe, but the universe doesn't need a cause, then any moment in the universe's history could come into existence just as easily as any other. And then through some probability jujitsu that he thinks he can pull off, you end up with the conclusion that more recent configurations of the universe are more probable than older configurations. And so then if you had the kind of modified causal principle that you just suggested, then we end up succumbing to the David's reductio, or at least that's what he's going to claim.
Right. But I was thinking about looking into the future. Like, could we say looking into the future, anything can happen because, hey, the causal principle is false? But if we restrict it to that, yeah, we'll have to talk about David's argument. But
yeah, right.
But we wouldn't have to worry about going into the future and saying things could just pop into my living room or whatever.
Right. Well, one way that people sometimes try to go is they say, well, if the causal principle is false, then there couldn't be then the only things that could constrain things from coming into existence are things that already exist. But something then couldn't constrain itself from coming into existence because it would have to exist before it existed. I don't think that's a very good argument for a number of different reasons. But look, here's something that we know here's a mathematical result from physics. So it turns out that if you're living in a Newtonian universe, not the kind of relativistic universe we've been talking about, but you live in a Newtonian universe, then if you have a collection of 5 objects, 5 point-like objects, and they're all moving around each other subject to a gravitational interaction, then within finite time, they can fly off to infinity. That's because on the one hand, as they fly around each other and come out and come back, their kinetic energy is growing. But the amount by which their kinetic energy is growing is completely compensated for by the amount that their potential energy goes negative. So the one thing goes off to positive infinity, the other goes off to negative infinity. The whole cloud of Newtonian particles goes off to infinity in finite time. The laws of physics are time reversal invariant. That means that anything that can happen in the forward direction of time can equally happen in the reverse direction of time. So if a cloud of 5 particles can fly off to infinity in finite time, so too a cloud of 5 particles can fly in from infinity in finite time and appear in front of you. That sounds an awful lot like the kind of examples that people try to imagine when they're imagining that what things would be like if the causal principle be false, right? William Lane Craig says, if the causal principle is false, why doesn't a tiger just appear in front of you right now? Well, here's a solution to the laws of physics that says that's actually what would happen, not if the causal principle were false, but if this other thing were true. If Newtonian physics had been true, then like a cloud of particles, 5 or more particles of the boundaries of the universe could come into existence and appear in front of you within the next 5 seconds. And of course, that doesn't happen. Now, in a relativistic universe, there's a very good reason why that doesn't happen. And that's because in many relativistic universes, the structure of space-time itself prevents such a thing from happening. Right? So things can't go faster than the speed of light. Because things can't go faster than the speed of light, they if anything did come in from infinity, it wouldn't be able to appear in front of you. Now, if you remember, there was that example that gave you of anti-de Sitter spacetime. And anti-de Sitter spacetime, because of the curvature of spacetime, things actually can come in from infinity and appear in front of you. But again, these are issues not about whether the causal principle is true, but about what kind of structure space-time has. And it's the constraints that space-time poses on the possible motions that objects could have that prevents something from coming into existence and appearing in front of you. So
let me bring it back to this Vilenkin model, right? There, it seems to me the constraint is the laws of physics. Like the laws of quantum mechanics do constrain what will happen, and the type of space-times that can come out, which ones are more probable, even though they are not causal relationships, at least according to Vilenkin. I mean, it depends on your interpretations of quantum mechanics and so on. But there is a constraint, it's not a logical constraint, but it is the constraint that the laws of physics give. Is that right or no?
Yeah, I think that's so. On Vilenkin's view about the laws of nature,
Yeah,
what happens must be one of the solutions to these equations. It must be some possible state of affairs described by the laws, and then you can ask, well, like, why couldn't you violate one of those laws? Well, the reason you couldn't violate one of those laws, on Vilenkin's view, was because what must happen is necessitated by these forms, or however it's supposed to go. And all these different views, but what you have is some sort of constraint that's imposed for some non-causal reason. And then that prevents all of these situations people want to imagine where, like, a raging tiger throws itself at you from the void, right? Like, that doesn't happen, not because things can't begin to exist without causes, but rather because there are other kinds of constraints on what can begin.
Right, and maybe the whole confusion comes about by that statement. If we lose a causal principle, there are no constraints, and we're saying that's not true. There are constraints, even if we drop the causal principle.
Now, here's another one. So there's this debate that people may have heard of, because it's one that's sometimes made up to the popular press. It's very closely related to this thing I was just talking about when I was talking about the space-time structure. So Roger Penrose famously has this cosmic censorship conjecture, according to which you couldn't have naked singularities. Right? So anytime you have a singularity, according to Penrose, it has to be clothed inside of a black hole, unless you're talking about the Big Bang singularity. That's the one, maybe exception. In fact, on Penrose's view, you couldn't even have that because he's got this other cosmological model. But anyway, if it's true that like a black hole singularity, for instance, must be clouds inside of an event horizon, then we can come up with examples where things come into existence without any prior cause, but then are trapped, can't get to you. So one example is if you have like a charged rotating black hole, then what the rotation does is it causes causes is the wrong word here. But if you have a rotating black hole, then the singularity is not a point singularity like it is in our ordinary example you might have seen in a documentary, but instead it's a ring. It's called a ring singularity. What's nice about ring singularities is that, unlike those point singularities, things don't just fall into them. Instead, if you were inside of one of these black holes, for instance, you could just hang out in there and look at whatever comes out of that ring singularity. And then the trouble is that absolutely anything out of the ring singularity. The ring singularity is a boundary to space-time. And as long as things are allowed to move away from a singularity, not just into them, then anything at all can come out. There's no constraint at all. In fact, there's no probability distribution defined by the theory over what comes out. So it's completely arbitrary what comes out. But if you live in a universe like that, then whatever comes out is constrained inside of that event horizon. And in fact, Penrose's argument for why you couldn't have naked singularities is precisely this: that that if you had naked singularities, if you had some point out in the universe where all these goblins could come into your universe from nowhere, then you're stuck in the kind of position that Craig worries about, where like a raging tiger comes out of the void. But if you don't have any naked singularities are always clothed inside of event horizons, then you never encounter that problem. The causal principle is false, and yet all the places where it's violated are they're cut off from you.
Right. So basically, the headline is Penrose protects us from goblins from another universe.
Yeah, right. So if Penrose's conjecture is right, and there are no naked singularities, then there's none of Craig's tigers either, right? All of that business doesn't happen, and not because of the causal principle, but instead because of the space-time structure.
All right. So what I want to do now is go to the argument that God would solve this problem. So let's imagine we're granting the problem is not solvable by the methods that we've had, And I'm gonna skip the thing about the dinosaurs, and we'll go on to how God solves this problem. We'll see how that might work.
Being typed on the keyboard, because a intelligent human being would have the ability to type, would have the knowledge to be able to memorize the first page of Hamlet and be able to type it out, and could probably be benevolent enough to want to save your life, right? So it's say the same with the universe, whatever caused the universe. Just because we have a cause for the universe, we still don't really have a reason to know which universe the cause would bring about, right? Why would the universe bring about? Why would the cause of the universe bring about a universe that began the Big Bang, where we can have generally true beliefs about reality? We didn't pop into existence 5 minutes ago, where we can study the cosmos and determine its age accurately. Why would the cause bring about that kind of universe rather than one of the many universes that would be, only 5 minutes old and just give us the appearance of age? And I will argue that we do have an independently motivated hypothesis, namely theism, an all-loving, all-powerful God, would be a great explanation for why for why we live in a universe where we can trust our memories, in which we can study a universe effectively and confidently. Because the all-powerful God will have the ability to bring about the Big Bang universe, but would also be all-loving, such that he would have good reason to want to create a universe in which we can trust our memories.
So, Alex, let's throw it to you here. What do we think? Is this a good explanation for why we live in this sort of ordered universe where we can trust our memories and our moral cognition? And
so, again, this is a brief thing. I haven't had access to the paper, so I don't know if he spells this out in more detail, but I suspect probably doesn't, realistically. I want to be charitable to the guy, but nobody ever really spells this bit out correctly. And I mean, this is a problem of the potential motivations of a divine creator, and very, very hand wavy, very quick there to say, well, maybe God, he might want to do this. It might just be the sort of thing he wants to do. So that's fine. It may be, the sense in which that's possible, that I'll grant without any further argument, is so thin. It's logically possible. Sure. But it's also logically possible that it's just some naturalistic explanation too. So it doesn't get you anything like just hand waving like that. I need to see more about why you think, for instance, a competent and interested creator is more likely than an incompetent or disinterested one. Right? So it's a classic Humean point, but still seems relevant if you're just hand waving the argument like that. You need to say more about it. The other thing I was thinking about this earlier today was this is quite tangential, but do you consider yourself to be a Jesus mythicist or a Jesus historicist? Right? In a way, I think these days my answer to that is that I just don't really know what the question actually is there. Because I say the question's easy: did Jesus exist or not? It's one of what do you mean? Who are you talking about? Oh, the guy in the stories. Yeah, but that's question begging in a way, right? Because it's assuming that the referent is settled in the first place, and it's easy. You just go, that guy, the guy that the story is about. But if it was a mythicist, then there wouldn't really be anyone that the story was about in the first place. And there might be a middle ground where it's if we really did rewind time and looked down the camera lens and see what was going on, that there really was a guy that it picked out. But maybe he didn't really have all the properties of the guy that we currently do. Maybe he was black or something. It's not what people think about, but most, what American people hang a picture of Jesus, he's just this white dude. It might be that that's, there might be some very, very real sense in which you go, oh shit, that's not Jesus. I thought Jesus was a different guy because of some distinct feature that he contingently actually had or something. So, the question of whether he's real or not, it seems to me it's too simple to just say, did Jesus exist? Even then, I want to be what do you mean, Jesus? What are you talking about? And it's here, I feel like the same thing's going on. It's we've got this handshake between us and the referent. That's taken for granted. Question's just, did this guy over here do it? But really, that's too quick. I mean, it should just be much more general. Is there a creator or no creator? And now we've carved up logical space in a way that makes sense, rather than just going, is this particular person I've got in mind the creator, or was there no creator? And it's just a weird question in the first place. And I think that maybe I'm just talking about the fine-tuning argument now, but the point's probably just completely commutable, right? maybe you think all of this is true, right? All of the reasoning is persuasive and it gets you to the conclusion that there was a mind that was behind all of this stuff, right? Let's just suppose I thought, like, maybe I think I'm a being in another universe that's on a particularly long space journey from one star to another, and I need to be asleep for like 1,000 years or something in order to, make the journey manageable. And what I do in that time is I program in a life to live, or a series of lives to live in a very hyper-realistic dream situation. And that's just what's going on now. One of the dream sequences I program in to just be this guy, and I just play some, random dude, blah, 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 these parameters. I can almost see this happening because, like, my life doesn't have any particular, like, huge tragedies. I'm not particularly important. There's nothing, like, remarkable. It's just like, I just want to have, like, a comfortable, normal life in this, like, middle-class England, 20th, 21st century, whatever, right? Just after World War II, just before World War III, whatever, right? Something like normal. I can sort of believe that, right? That would answer the fine-tuning question, because why are all these laws of physics? Because it's the simplest way of running the simulation that my computer makes for me whilst I'm on the hyperspace. But it doesn't tell you, you can't say, well, there's a fine-tuning problem now, because who made the creator or something? Because, well, we don't know whether their laws are fine-tuned or not. So we don't know anything about them. It might be that in the actual laws of physics that they live in, it's not fine-tuned, it's coarsely tuned, so that like massive variations are still susceptible to life. In which case, I can infer something being there, some kind of mind, but I can't infer anything about it being Christianity or theism or anything. I just get as far as the mind bit. With that hypothesis, I just came up with that sci-fi story I just told you about being asleep in a hyperspace travel in a new dimension or whatever. That's just as good, it seems to me. And like, can't I say something here? Like, if you thought all of this stuff was right, the kind of appeals that David's making now, couldn't I just say, oh yeah, the simulation that I'm running definitely didn't start last Thursday. It's been going for 1 billion years or something, internally or whatever to the simulation. It's been going on for 1 billion years. Because the creator wouldn't have, because hand wave creator motives like he's just doing, but just assign them to the person running the simulation. And game over, right? So there's been two problems. There's a failure of reference. I don't know what you're talking about. How can you just point at someone and say, is this the author of all of this stuff around us? I don't know what you're talking about now, like with the Jesus thing. And the second thing is I just think a more modest hypothesis could just do all of the explaining as well. So it's like unfair to zoom in on the one hypothesis that he likes that has all of that explanatory power and forget about all of the sort of fanciful sci-fi scenarios that you can cook up that have exactly the same explanatory power, it seems to me. They're just not
right. And I can imagine like Draper's ascetic God, where it's like the purpose of the universe is to tell a great story. Well, a great story, will have this long evolution of the universe, and it wouldn't have, everything began last Thursday. That's another competing hypothesis rather than the perfectly good God.
Yeah.
And that's not included in the probability calculus here. Dan, what are your thoughts on this? God solves it.
Yeah, I mean, so this is basically the gap problem, right? And the issue with the gap problem is always that.
Hang on, just for the viewers, not everyone knows what the gap problem is.
Yeah, right. Okay, sure. Yeah, of course. So the gap problem is this issue it happens with various arguments for God's existence, that you establish some conclusion and you notice, hey, like actually the conclusion of that argument did not succeed in establishing God's existence, it established less than that. So, the Kalam argument, the first stage of the Kalam argument establishes that the universe has a cause, right? That's what it succeeds. That's what it establishes if it succeeds. And then they want to say, oh, there's the second stage of the Kalam argument, where what we do is we show that whatever the cause of the universe is has to have various divine attributes. And then that's why we should think the cause of the universe is God. And of course, you could switch out the Kalam argument for the fine-tuning argument or various other theistic arguments. And what's been pointed out again and again about the gap problem is that even if you think that the first stage of any of these arguments is particularly strong, the proposals for solving this gap are extraordinarily weak. And so it's in a way, like an atheist could just concede the first stage, the claim argument. They could say, yeah, the universe has a cause. Now what? And then it turns out that anything that the theist wants to say, now that that's been conceded, are just really, really poor arguments. There's a long video that I did with Joe Schmidt a while ago on precisely this issue. But yeah, I mean, so for instance, they could say, so Craig sometimes says, oh, well, the cause of the universe needs to be an intelligent mind of some kind, because only a will would have this kind of spontaneity. Well, really, I mean, that conclusion can't be established. What you could establish, maybe, depending what your views about free will are, and again, that's self-controversial, is that free will endows an entity with this kind of spontaneity, but that leaves completely open whether something else could do the same thing. I mean, in a way, it's sort of similar to the flaw we were talking about a while ago when we said that, yes, causes constrain their effects. That doesn't mean that without a cause, that there would be no constraints. And likewise, yeah, maybe something with free will, depending on how the free will debate gets settled, maybe something with free will would have some kind of spontaneity. That doesn't establish that that only something with free will would have that kind of spontaneity.
Now you've said it like that, it's just a confusion between a sufficient condition and a necessary condition. It's like saying, well, if it's the presence of a all-powerful, spontaneous will, mind, divine being thing is sufficient for there being a universe, right? Because if there was one, then there could be a universe, something like that. And then it goes, so therefore it has to be, right? Therefore it's necessary, right? No, it's not, right? Like it's, I don't know, sufficient that I have $1 million in my bank account for me to be rich. It's not necessary, because I could have like 999,000 or whatever dollars in my bank account. I'm still rich. I'm $1 less. It's not required. It's only sufficient for that. So
right.
Yeah, sure. Saying a God's sufficient for this kind of creative act doesn't mean it's the only way that you can get there. It could be some other way.
That's right. Yeah, and it leaves completely open whether there could be anything else, right? I mean, importantly, and this is another point that sort of gets always, or maybe often swept under the rug, is that the fact that you can't think of a hypothesis doesn't mean that there are no other possibilities. It could be that all the hypotheses that everyone's ever thought of are very improbable. That just means we don't know what happened, right? It doesn't mean that that you have to like choose one of the improbable hypotheses. It just means that whatever the correct explanation is, maybe just hasn't been thought of yet.
Could we say that whatever the fundamental structure of reality is, whether it's quantum fields or something much deeper, something else, that they just have to have that property that there's some sort of spontaneous action going on? That it doesn't have to be a free agent, in mind with free will.
Right. So on the one hand, I don't think that the arguments that it needs to be spontaneous are very good arguments.
Yeah.
And on the other hand, if that argument succeeded, then yeah, you could have some physical entity that had some kind of spontaneity to it. And Craig wants to say that only something with a certain kind of free will would be able to constrain itself and then like only release sometime. But like, I don't really understand even how this is supposed to work, because we're imagining that in this state where God is constraining God's self, God is timeless. It's not like God has to like constrain God's self like a certain amount of time, right? And so that I don't know that I completely understand what the point is supposed to be, but right. I mean, but that's one example of how standard ways of resolving the gap problem are not very persuasive, and that's not just true about this issue about spontaneity, but true across the board. Like any way that I've ever seen to try to resolve the gap problem has been a very weak argument. And if you notice, people often just debate the first part of the argument, right? Like when apologists present this sort of material, the second stage almost comes off like an afterthought. And all the work has been put into presenting the first part, which really the atheist could have conceded anyway.
It's like, I think the original gap argument is from Aquinas, and it's basically just you tag on to the end of your cosmological argument. You just tag on a sentence and goes, and that everybody recognizes to be God. And then you
Yeah. Yeah.
Lose it.
And it's like, well, something powerful enough to create the universe is God, like, well, there's lots of ways to define God. And I always thought that maybe there's just some trick that you need to be able to create a universe. And if you know the trick, you can do it. A bit like making a nuclear bomb. You might think if I went back in time 2,000 years ago, I said, I can destroy a city at a push of just a click of my fingers. Well, that must be a God. Must be. No way just an ordinary mortal could destroy an entire city. I mean, the cities were smaller then, granted, but, there's that sort of area. Well, no, it turns out that, mortal men can do it. But they just didn't know the trick to it. So maybe making a universe is like that.
Well, my dog thinks that I make her biscuits appear out of ex nihilo each night because she doesn't know where the food is kept. It's like on the shelf above where she can see. So I just put the bowl up there. I do some magic and then it comes back down again with food in it. And she's like, amazing, you must be God. So I like that. It's good for my ego for there to be a little being that thinks I'm
lately I've been sort of suspecting that there may be a sense in which beginnings don't really make sense to talk about given what sort of structure our universe may have. But in any case, that's something we can talk about in a future episode. I think there's one more clip that's
right. So the last thing, and we're obviously pushing after 90 minutes. Of course we are. Well, that's I will find. So it's this thing called the mentaculus. And there are these three conditions. Why don't you, Dan, very quickly, because we are after 90 minutes, as quick as you can, what is the mentaculus? And then we'll hear what David has to say about it.
Right. There's three hypotheses. The first one is the past hypothesis that the universe began in a very low entropy state. The second hypothesis is the fundamental dynamical laws, the laws of physics, whatever they turn out to be. And then the third condition is that there's a uniform probability distribution over all of the microphysical states consistent with the observed macrophysical state. And the idea that David Albert, among others, has had is that all the probabilities that we have in the sciences should be conditionalized on those on that package of hypotheses. Right.
And just a little bit of trivia. The term mentaculus came from a Coen Brothers movie.
Yes, it did. Yeah.
Yeah. All right. So let's see what we're talking about here with David's reply about conditionalizing on the mentaculus.
When we're doing science, we're presupposing the mentaculus, these three conditions. And you have to presuppose them for science to work. So, well, I would argue we can presuppose those. Let's operate under the assumption that we have those three conditions met. The universe really did begin with the Big Bang, right? If we actually, believe the universe began on cause, we can start with these presuppositions. And we say, okay, if those presuppositions are true, but, if the universe actually began with the Big Bang, those presuppositions wouldn't be true. Therefore, we wouldn't expect all of these different, ways to measure the age of the universe to be correct. Like we can say, we have to trust that we can get scientific results in the first place before we can go out and measure them. But what we'd expect if the universe began cause is that assumption is wrong. We actually can't trust our scientific understanding because all these estimates for the age of the universe are false, right? So we start with that presupposition, but we actually turn out that presupposition must be wrong, given that we can't actually measure the age of the universe accurately.
Right.
So go ahead.
No, you go ahead. Go ahead.
Yeah. Well, what's going on here is that so David comes to this place at the end of his paper where he wants to say that not only are atheists saddled with this bad conclusion if they want to say that the universe is continuing without causes, but that in fact we can look out into the universe and we can see that the universe is 14 billion years old. And there's multiple different independent ways of measuring this. And those ways of measuring wouldn't all agree if the universe were just 5 minutes old. There'd be no reason to get that kind of broad agreement. No, in this point in our conversation, I said to David that, well, if I concede all the arguments that I've made, if I say, yeah, the atheist is saddled with this, and that we're now in this position where we want to look out and see like whether or not the universe is young or old or what's going on. What's going to happen is that we have to give up the mentaculus in order to say that. right? Because part of the mentaculus is that the universe is very old and has this low entropy condition in the past. And then if we give up the mentaculus, it turns out that the most probable way to have this broad consilience among your different cosmological measurements is if, in fact, they just popped into existence a moment ago. So this is what's called in other contexts, it's basically what's called the Boltzmann brain problem. That if you think that states can just come into existence basically randomly, then what you expect is the highest entropy state consistent with all the data that you have. So the highest entropy state, in this case, consistent with all of your cosmological measurements. Well, the highest entropy state that's consistent with all of our cosmological measurements isn't one where those measurements represent an actually old universe. It's one where the universe is, in fact, very young. If we allow for truncated spacetimes, it's one where the universe gets truncated just a moment ago, right? It would be more probable that the universe began last Thursday than that these measurements are actually veritical and tell us about an actually old universe. So in fact, either David needs to accept the mentaculus and then accept that our universe is very old, or else accept the skeptical conclusion that he's trying to saddle the atheist with.
Right. So you can't reject the mentaculus and then keep the conclusion that you want.
Right.
It's going to be dependent on the mentaculus.
Right. The skeptical conclusion returns if you reject the mentaculus. And so so like what you end up with is just the Boltzmann brain problem all over again. What was strange about this to me in our conversation was that there's a footnote in which David talks about some of these issues, cites me for them instead of citing David Elbert, and then doesn't really quite see that they have these implications. So I don't quite understand what happened there, but
just an amusing little quip. Barry Lower's involved in the mentaculus, and I remember him saying something like, "How do we know God doesn't just really like Boltzmann brains?"
Yeah, right. So there's a similar thing you can put in terms of Penrose's entropy calculation. So Penrose's entropy calculation gets repeated all over the place. It gets repeated, in fact, in some of the footnotes in David's paper. But Penrose isn't doing a calculation that shows that we're probably Boltzmann brains. Instead, what Penrose does is he says, look, let's take for granted that everything in, say, our galaxy is as we think it to be. What is the most probable state? Well, it's one where you have the galaxy and maybe some surrounding space, but then some high entropy condition all around us, so that in that case, instead of one brain having an illusion, it's like all the denizens of a galaxy having an illusion. Why does Penrose talk about that? Well, what Penrose is interested in is this anthropic fine-tuning, right? So Penrose is interested in the question: does the entropy that we observe the universe to have explained by the fact that we wouldn't be here were it not that low? And the answer is actually the entropy could be a lot higher and still allow for the existence of all the different things that live in the galaxy, wherever they may be. So anthropic selection doesn't give you an entropy as low as the one that we observe. That's a problem for theists, because if you have a theistic anthropic explanation that, like, God really likes living things, then you haven't explained why it was that God made the rest of the universe have as low of an entropy as he made it have. Some people, like Barnes, think that they have an explanation, but the explanation they give is just that, God could care about other things too. And it's like, well, yes, I know that God could care about other things too, but you haven't told me what he cares about in your hypothesis, right? All you've done is you've just said, there could be something that explains this data. Well, yeah, I know that. But the trick here is to explain the data that we have, given the hypothesis that you've given me. In any case, as it comes to David's argument, we really would be stuck with this Boltzmann brain problem if we come to the place that he wants to come to at the end of the paper. What he seems to do in the clip you just played is he seems to concede to me the mentaculus, and then tries to rebuild his arguments anyway. So I don't quite understand why he thinks that he can do that.
Alex, any last thoughts before we sort of wrap things up?
No, although maybe what he was trying to say, just to be charitable, I guess, is, does this make sense that you're keeping the mentaculus as a kind of fixed point, but I suppose, can he say that constraint is something that like last Thursdayism can comply with? Because,
no, so the argument for accepting the mentaculus is that if you don't accept it, then you have to accept something like last Thursdayism. So if you look at where like David defends the mentaculus as he says it's not the usual kind of empirical argument. It's like a transcendental argument. It's like you have to presuppose this, or else you get a radical skeptical consequence. And that radical skeptical consequence undermines all of the science that you did to come up with this thing in the first place. So it's sort of unstable. So the stable point to go to is one where you presuppose it. Otherwise, skepticism moves.
Right, because one of the arguments actually we didn't play a clip on was, hey, look, the measurements of the cosmic microwave background and the measurements of various other things, they all coincide.
Right.
Actually, technically, the Hubble tension says they don't, but leave that aside. It's not going to be relevant to the argument. But, so, hey, this is really strong evidence that the universe must have had a cause, because if it didn't, anything could have happened. But if it did, then all these things would coincide, like the age of dinosaurs and the age of the sun and blah, blah, blah. They all do coincide. So therefore, we can make this conclusion. But if you don't accept the mentaculus, then you can't accept that evidence either, right? You can't run that argument. Am I getting that right?
That's right. So one thing important to point out here is that the mentaculus doesn't itself tell you how old the universe is, but it does tell you the universe has to be very old. It tells you this low entropy condition has to be in the distant past. And then you're allowed to make inferences about all the things that happen in between that low entropy state in the distant past and the present. People who maintain the mentaculus also have this view that the record formation, for example, is going to be explained in terms of the mentaculus. But if you didn't presuppose the mentaculus, then you wouldn't have heretical records at all.
I guess I was thinking that he might be supposing that the mentaculus is something that itself could have come into existence, last Thursday as well. In which case, doesn't escape the hypothesis, right?
We could be mistaken to presuppose the mentaculus. That's possible. But if we are, then we're stuck with radical skepticism, right? So what's interesting is that David has found a few different arguments for theism that very closely resemble arguments that are in philosophy of physics, that it seems not to recognize that correspondence, right? So there was the debate about maximal extendability, and that resembled this argument you had about the causal condition, or sorry, the causal principle. And then there's this issue about the mentaculus, which is similar to this issue about being skeptical about the past. That the usual argument for the mentaculus is that if you don't presuppose this, then you are going to have basically global skepticism. And so if you don't want to be a global skeptic, then you must presuppose it.
But imagine we were talking about, I guess, maybe it's still last Thursdayism. If we're focusing in on my memories and stuff, right? I could have just popped into existence, say 5 minutes ago, with all of my memories intact. And then the equivalent sorts of things that David was saying in the last clip would be what are the coincidences that the key in my pocket fits the lock in my front door? And what are the coincidences that the name on my passport is the same name that my wife is calling me, and stuff like this. And he's trying to say, well, it'd be incredibly unlikely that all of those things would line up, if it's just popped out, 5 minutes ago. But the equivalent from there isn't really an equivalent of the mentaculus in this context, but it would be something like, at least the past hypothesis bit of it would be like, that you actually are a person who's, roughly 40 years old, who was born by blah, 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 in 1980, whatever. But surely, I mean, if someone's in, like that film Memento, where you can't remember what's happened to him before the last day, in that situation, any rule like that you want to adhere to, it must be that I was, 40 years old or something. Surely that belief and anything that gives me reason to think that belief is true would have also come into existence last Thursday, right? And isn't that just as, like, how are you allowed to say, oh no, but that's fixed or something? Whereas,
look,
the thing is like trivial. Like, it doesn't make any sense.
It's a transcendental argument.
Yeah.
Right? So like, I mean, it's similar to how Kant does things, right? So you say, look, what does Kant say about causation? Kant doesn't say that we have like a priori deductive proof that there is causation. He says, look, if you want to make sense of your experience, then you have to presuppose causation. Otherwise, your experience isn't going to, I don't know,
be a booming mass
of
confusion or whatever he says, right?
Right. Yeah, that's right. And so the view here is that on the one hand, we discovered thermodynamics and all the stuff that goes into the mentaculus empirically. But once you discover it empirically, what you also find out is that in order to escape global skepticism, then you must presuppose it. That you're not going to have some way of the world's not going to be sensible to you unless you do presuppose it. Right? So the view isn't that I can go out and prove that the mentaculus is true. I could be having a dream right now. Part of the dream could be that I believe the mentaculus.
Yeah.
But if I do have access to the external world, that's really the only cognitively stable position I could be in. Then I have to presuppose the mentaculus. Right? I mean, So
the argument is you can reject the mentaculus, but it's going to be cognitively unstable in that it's going to threaten all your other beliefs.
That's right. Yeah, including all your beliefs about science, for example. Right now, as far as the consilience between all the different measurements, he was sort of flabbergasted that I said that, like, well, if you gave us the mentaculus, and the most probable thing would be that they all accidentally align. Remember the Boltzmann brain scenario, right? So in that, what we're thinking about is that if you want the most probable configuration that's consistent with all of the data, then the highest entropy state that's consistent with all of the data is that all those measurements just accidentally align. Otherwise, you need this much larger low entropy universe in which all the measurements align, right? Thermodynamically, it's easier to have a smaller universe or smaller region of a universe in which all the measurements accidentally align than a bigger universe in which there's a good explanation as to why they all align. So you're not going to be able to, like, settle this by going out and taking all these measurements and seeing that they all match up with each other.
Yeah.
Like, if you take last Thursdayism seriously, then last Thursdayism has a perfectly good, you should still be a last Thursdayist. Right?
Yeah.
Like, that's what you're stuck with.
Yeah. That seems to be something quite sort of, and I guess it's because the argument was put forward as a kind of reductio or something, where it was, you're supposed to believe this as the person who holds the opposite of my view. So I'm going to, like, describe it. But, there was something a bit strange about, like, obviously, if no one actually believes the universe came into existence last Thursday, but if they did, that person would have, like, a flat earth, a ready explanation for why all the particles are where they are or whatever. Like, it wouldn't be like, it's exactly what their hypothesis predicts. I mean, of course, it's saying two things. Everything is what you're seeing right now, any empirical observation that you've got, you have that. Second thing, reality began on Thursday, right? And so you can't go, but this star is in this position in the sky. yeah, that's what the theory says. Any empirical stuff, we've already got that. So like,
Right.
there's something kind of like wrong in principle about sort of like asking, like there was a bit where he said, oh, all this particles that are in the past light cone would have had to have just sprung into existence last Thursday, including the sun, as if that made any difference. Like, because the sun's got loads of particles or something, that makes it less likely. But it's not relevant. Doesn't matter.
Right.
The numbers don't make any difference. So there was something fishy going on there. But yeah.
All right. Well, look, I think we should wrap things up because we're going to about 2 hours now. So if you're happy, guys, to do that, yeah. So let's wrap it up. If you have any thoughts about this, please leave them in the comments. If you like this video, please give it a like and subscribe, and we will see you next time on the Sci-Fi Show.